Welcome to my presentation. In this presentation, let us look at some geometric properties of cross product. In here, if we have two vectors, vector u and vector v, and if these vectors are non-zero vectors in R3 space, then the following properties are true. Then, property number one, we're going to say that vector u cross vector v. These two, when we cross these two vectors, they will be orthogonal to one another. That means perpendicular to one another. The second property is the angle between these two vectors, vector u and vector v, can be written out as follows. We're going to take the sine of the angle, sine theta, is equal to vector u cross vector v, and we're going to take the magnitude of that divided by magnitude of vector u times the magnitude of vector v, that way. Okay. And the third property is saying that if u and v are parallel, if and only if vector u cross vector v is going to go to 0. These two vectors, vector u and vector v, will be parallel. That means they will be if this is a vector and this is another vector, if this is vector u and if this is vector v, they are considered parallel if they don't meet, when the endpoints don't meet each other. They are parallel to one another if and only if. The condition then is if vector u cross vector v is equal to 0. If that goes to 0, then those two vectors are parallel. The fourth property is telling us that if u and v are adjacent sides of a parallelogram, then the area of the parallelogram is given to us as follows. Let me explain this. A parallelogram is a four-sided figure. It is like a skewed rectangle. A parallelogram looks like a skewed rectangle. So two long sides are parallel and then two short sides are parallel. That is how a parallelogram is defined in geometry. If we say u is one side of a parallelogram and v is another side of the parallelogram, then the area of a parallelogram in terms of vectors can be stated as follows. The area, let me write this as area. The area of a parallelogram can be given as the cross product between vector u cross vector v, and we're going to take the magnitude of that, and that will give us the area of the parallelogram. We will use some of these geometric properties of cross product and then try to solve some simple example problems in my next presentation.